This example says, in the circuit shown in figure we are required to find the current flowing through the battery. We need to assume the diodes are ideal. We have two situations given to us. Let's discuss both of these one by one. In the situation shown in figure we can see that the battery will supply the current in this direction. And when current is flowing from right to left, in this situation we can see that the diode D1 will be reversed biased because current will not be allowed to pass from N side to the P side of this diode, so this will be reversed biased and it'll behave like an open circuit, as we need to treat diodes are ideal. And this current will pass through D2 and whole current in turn will pass through the 4 ohm resistance. So for this situation A, if we draw the equivalent circuit diagram, it'll look like this situation. Here we can see that this diode D1 is reversed biased and D2 is forward biased, so current will pass through it, or it'll act like a straight wire. And there is battery of 30 volt resistance connected across it, these resistance of 6 ohm, 3 ohm and 4 ohm respectively. Now the current is passing through it, these two resistances will behave in parallel. And 4 ohm will act, as it is connected in series with these two in parallel. So here we can write the equivalent resistance of the circuit will be 6 and 3 in parallel will be given as 6 multiplied by 3 by 6 plus 3, and as 4 is in series it'll be plus 4. So this can be written as 18 by 9, it is 2 plus 4 in all. The equivalent resistance across the battery will be 6 ohm. And current through the battery can be directly given as 30 by 6, is 30 volt battery. So at 30 by 6 that will be 5 ampere current which will pass through it. That will be the answer to this problem. And be careful, here we have analyzed the diode D2 is forward biased, because in this case current will flow from P side to N side, because the current cannot flow from N side to P side of the diode D1. Similarly, if we analyze the situation in figure B, the battery is reversed. You can see the positive side of battery is connected to the left side of this circuit. So when current will pass through it, you can see the current will be going from left to right side. Say here you can see that diode D1 will act as forward biased, and when current will approach here, in this situation you can see the D2 will also act as a forward biased diode because the current has to flow. Here when current will approach from D1, it is two paths to flow. One is from 3 ohm, other is from D2. And obviously we can see the potential of this side, which will become 30 volt, and this will be less, so D2 will be forward biased and current will flow through both of these directions. So the equivalent circuit here we can draw as this will be the 4 ohm resistance, and here 6 ohm resistance and 3 ohm resistances are there. And this D1 will act as a straight wire because it is forward biased, and the battery of 30 volt is connected across the circuit. And in this situation you can see that due to forward biasing of diode D1, this 4 ohm is short-circuited. So whole of the current will pass through D1 and the current through 4 ohm will be negligible, or we can treat it to approximately V equal to 0. So here, the total resistance across the battery can be written as only 6 and 3 ohm in parallel, because current would always be flowing through the low resistance path in the beginning, and then it'll be distributed between 6 and 3 ohm resistance. So here equivalent resistance will be 6 into 3 by 6 plus 3. That will be 2 ohms only. And current through battery can be given as 30 by 2. This will be 15 ampere. That will be the answer to the part B of this problem.